All right, this video is going to be on the Doppler effect. And the Doppler effect, I'm going to give it a fancy definition. It is the change in frequency due to the relative motion of a wave source and an observer. Now that sounds kind of fancy, but you've actually all heard the Doppler effect before. Okay, if you were at a racetrack and there's a car going by you, as it comes towards you, it's going to sound higher pitch, and as it goes away, it sounds lower pitch. So as the car is coming towards you and goes by, you hear this meow sound. So it starts out higher pitch, ends up lower pitch, and that's called the Doppler effect. Now, this is my source of sound right here, okay, and it's sending out sound waves in all directions around it. They look like ripples on a pond, but this source is moving to the left, okay, so it's moving towards this person. If it's moving towards, say that the wavelength gets squished, so the wavelength is shorter, that means the frequency is higher. For sound, it's going to sound high-pitched, higher-pitched. Or for light, we're going to say it has a blue shift. Okay, red is the longest wavelength, violet is the shortest. We'll call the violet end the blue end. So light is going to be shifted towards the blue end. All right. Now the source of sound is moving to the left, so it's moving away from this observer. In that case, the wavelength gets stretched, so it seems longer wavelength and lower pitched, or lower frequency. So sound is going to sound lower pitched. And light is going to be red shifted. So when we say light's going to be red shifted, it's not going to be obvious for things going normal speeds that their color is going to change dramatically. It's only changing, way less than we detect. Or it might be that if we're studying something in astronomy, it may not be light being red shifted, but it might be X-rays moving to a slightly lower frequency. So redshift is a catch-all phrase for longer wavelength. And one use for this is police radar. Okay, it sends out a radio wave. Which gets reflected back. And if you have a bigger change in wavelength, that means that the car is going faster.